Sam, does my mic sound okay, by the way? It's been clipping recently in meetings.
You know, it might be just a hair over mod, but no one's going to care. Like, say another couple words.
Testing, testing, 1, 2, 3. Testing.
It sounds like you're on a laptop mic, a speakerphone, but it's...
I am. I'll just put on my headphones.
No, it's fine.
Okay.
It's fine. It's within the realm of normal.
Okay. That's all. I think that's the best I personally can hope for.
Having just been on the sound crew for an event this weekend, like, they care more about sound. We don't. As I watch the trickle of people, as much as I want to start on time, I'm going to give it another minute and a half. All right, colleagues, telling you things you already know. The session's being recorded. Things that you say here, if you or your organization have patents on them, those need to be disclosed. Please be nice to each other, be respectful to each other. If you feel that that's not happening, the IETF has ombuds people who are happy to help, as of course are your chairs. And because we're an interim meeting, we don't have to worry about a lot of the details, but please don't have your audio or video on unless you are actively speaking. Headsets are great. And then agenda bashing. The point of this meeting is to figure out whether the first RFC coming out here is going to support heavy hitters or not, and if so, how. Those are the questions we want to answer today. If we have time, Junia has asked for time to talk about Pine. Any other business or any agenda bashing? Go ahead, Tim.
Thanks. So I think you correctly framed it as like we want to decide whether or not DAP will do heavy hitters. But the related discussion though is like what this working group might do about heavy hitters outside of the scope of DAP specifically. So I guess the pedantic agenda bash is that I think we should like be prepared to discuss how we would approach heavy hitters outside of the scope of DAP itself.
Very good.
But I'd be open to, yeah.
Thank you. Anything else? All right. Chris and Tim, I understand you're splitting the presentation. I'll let you do slides.
All right, I'm starting out here, but I'm struggling to figure out I click the button.
Yeah, hit it again.
Okay. I don't see. Do you need to stop sharing slides?
I did stop sharing slides. I'm just having to find the button to approve it.
So you have to mouse over Chris's icon in the queue, and then there should be like a grant slides button there.
Do it again, Chris.
No need. I have the pop-up now, and I am sharing my slides. Okay. Okay.
Also, we do have the Zulip room open, as some of you have seen, in case people want the back channel.
All right. Sorry, I'm trying to figure out if I could. I guess this is good. And oh wait, there we go. Cool. All right. Okay, let's get going. So as was mentioned, today I'm hoping that we can decide if and how to support heavy hitters. I think everyone in this room I see has already seen this document that we've been working on. In fact, most of the people are here. So, but I just wanted to give a quick shout out to the people who gave feedback on this and helped us kind of figure out what direction to go in. So let me I think it's worth level setting anyway, just so we all understand the nature of what this would mean for DAP. So the problem we're trying to solve is we call it the heavy hitters problem. You have a threshold T, and each client is submitting just an arbitrary bit string, and you want to know which bit strings were submitted at least T times. So this has tons of applications. Basically, you want to know what is kind of the most important thing in your metrics to pay attention to. So I think kind of the most common use case is the use case to think about is what are the most popular URLs that users of your web browser are visiting. So this problem is solved by this VDAF we call Popular 1. This is based on a paper from 2021, and it was kind of like the first demonstration that you can solve this problem in a performant way, on the order of say 30 minutes to an hour. So before this paper, this was not possible. And the thing that makes it possible is this thing called an incremental distributed point function. So what this allows you to do is you have secret shares of some user's measurement, and you can ask, is this measurement prefixed by a particular string? We call these strings candidate prefixes. So this functionality allows us to do is basically count up how many measurements of these input measurements begin with a certain candidate prefix. So we call this prefix counting. So so all of this kind of happens. What's nice about IDPFs is all of this kind of happens server side. The clients upload their reports, and the aggregators can do computations on them such that each can compute a secret share of the prefix count for each candidate prefix. So the way we use this functionality is the collector specifies this sequence of candidate prefixes, sends it to the aggregators. The aggregators compute their shares of the counts for each prefix, and then send that to the collector. And then the collector is going to use this information to pick the next generation of prefixes. So basically, if some prefix P has a count above the threshold, then we're going to add its like P plus 0 and P plus 1 into the next set of candidate prefixes, and so on. So just a kind of, I think it's helpful to have an illustration. Basically, we're doing this tree traversal thing. So what I've drawn here is kind of the binary tree. So each edge of this tree is labeled by a candidate prefix. And in the nodes, we're going to put the prefix counts. So this kind of table here, I guess you probably can't see my mouse, but the table on the left side of your screen, this is our kind of this is our sample set of input strings, and we're going to run heavy hitters over this set with threshold t equals 3. So the first thing we're going to do is count how many inputs begin with a 0 or a 1. In this case, we have 30 inputs that begin with 1 and only 2 that begin with 0. So 2 is below the threshold, so we're done traversing this side of the tree, the left side of the tree. But on the right side of the tree, we certainly have data that we're interested in, so we're going to add its children into the set. So we're going to traverse 1, 0, and 1, 1. And in this particular example, we see we get a count 16 and 14. Again, both are in this over the threshold, so we add their children to the next generation, and so on and so forth until we reach the bottom of the tree. So this is how kind of tree traversal works. So at each node, we're computing, the aggregators compute shares of this prefix count, this that's shown in the node. They have secret shares of this. We add them together to reveal the count, and then we use that count to make a decision about what direction to go in next. So does anybody quickly have any questions about that? I'm guessing no one here has questions, but maybe the chairs do.
To be clear, if your threshold were, say, let's say your threshold is 2, you'd go down multiple paths, right? Yeah.
So if your threshold was 2, then going back up to here, we would have added both 0, 0, 0, 1, 1, 0, and 1, 1 into the next generation.
Thank you. And by the way, for the record, the chairs are concerned about the attendance today.
Yeah, I don't know what to do about that.
But
okay.
Continue, please.
All right, I'm going to keep going. Okay, so the next thing I want to point out here is in this traversal, we've learned some information about our inputs. So what we wanted to know, what are the heavy hitters? And the heavy hitters are these strings that kind of go along these cyan highlighted edges. So we have 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, 0, and 1, 1, 1, 1. Those are all the heavy hitters. But what you notice is that we've along the way to computing these heavy hitters, we've learned additional information. So this is inevitable. This is how the algorithm works. We can't avoid this without adding something on top of IDPF. That is Poplar. And it's actually worse than this. So something that we've been talking about for a couple of months is a threat of what we call steering attacks. So the observation is that in our threat model, we imagine the collector is malicious, controlled by the adversary, and so is one aggregator. So what we're assuming is that one aggregator is honest during this computation. So this means in our threat model that the attacker gets to pick the prefix tree that we traverse. It learns the prefix counts first, and it it basically tells the aggregators where to go next. So yeah, so we can partially mitigate this by just kind of adding some restrictions on how traversals can go. But the thing that we can't do anything about is this thing called an additive attack, which I'm going to describe now. So here our starting point is the same. Like we are just going down the tree, and then so we're kind of like going back to this first level. So we notice 2 and 30, and we're like, well, I'm interested in what that 2 must be. There must be something juicy there. So what I can do is just lie about the prefix counts. So I add, in this case, I add 1 to the left child, and I subtract 1 from the right child, and now the hit count is 3, and I can go ahead and start traversing to the next level. So that's what I do. So I discover that this is so this is kind of a no-op level, but I need to keep going here because I need to lie about the hit count on the left once more. And we kind of do this until we get to a point where, like, you know, we've learned something we weren't supposed to learn. So we have found that 0, 1, 0, 0 is in the input set, even though it's not heavy hitting. It's a light hitter is what we've been calling it. So yeah, so that's kind of how the attack works. Does anybody have questions about this attack? Okay, hearing none. So this is sort of inevitable in our threat model. What can we do about it? Well, the thing that we know that we must do is add differential privacy to IDPFs in order to make them secure. So differential privacy is something this working group has discussed. There was a draft proposed a while back. And hasn't gained much traction, I think mainly because we haven't had an application, but well, here's an application. We need differential privacy for this. So what intuitively differential privacy provides is we're adding noise to the prefix counts that we compute at each node. And what this does is just introduce some uncertainty about the true hit count. So I kind of flashed back and flashed forward. So the true hit count there, you can see at 0, 100. 0, 1, 0, 0 is 2. And I don't know, in this example, I kind of like just sprinkled in some noise by hand. We see that we have 2 nodes. One has value 1, one has value -1. Well, like what does an attacker make of that? The fact is that we do have non-negligible information that we're not supposed to have, but we do have some uncertainty about whether what we're looking at is true. So it's obviously a lot more complicated than that. Formalizing this security property for Poplar 1 is very, very, very much possible, and we can actually have a security, like a theorem that tells us how do we relate the parameters that we choose to do DP to the chances of an attacker succeeding at this attack. So that's differential privacy. This is kind of the tool that we know we're going to need. However, I want to mention a couple of other things that have been brought up really over the last year or so related to this problem. So another way we might try to mitigate this is by bolting on additional crypto. So what's been observed is with general purpose MPC, we can pretty much do anything we want. In particular, we can say, like, I have a share of the prefix count, you have a share of the prefix count. We want to check if the prefix count is above the threshold without actually learning the prefix count. And this would be a useful thing to do. It means we don't need to reveal prefix counts to the attacker, and this makes guessing harder, in particular steering attacks harder. Another way we might use general purpose MPC is the way from the Poplar paper to add differential privacy noise is each aggregator kind of samples noise and adds it into each of its prefix count shares. And this works just fine, but we add more noise than we actually necessarily want. So we can get better performance if we have a way of like sampling precise shares of DP noise, such that like we have a share from a sample of the distribution that we want. I see a hand. Do I see a hand?
You do.
Go ahead, Tim.
Sorry, I have to pick a nit. You just said we get better performance, and I wanted to clarify. Like, I think what you mean there is better sort of utility, and that you apply less noise.
I mean better utility. I don't mean that faster. This would obviously be a lot slower. So yeah, as Tim points out, we are basically in the two-party setting for MPC with DAP, and this is probably too expensive in the two-party setting, based on feedback that we've gotten in various channels, but we don't necessarily have a definitive answer. But I also wanted to point out that Martin Thompson and gang are pushing on this new MPC framework that enables things like IPA, and in this framework, it might be possible that we can do things much more efficiently. And then just to kind of like round this out, there are also different approaches to heavy hitters that are possible. So something that this working group has discussed is STAR. This did not gain traction ultimately because there is a DOS attack that was discussed and we couldn't figure out how to mitigate it, at least not efficiently. The potential upside is that we get much better performance than Poplar, within the same threat model, and in fact, there's this recent iteration of STAR called PopStar that kind of shows you can get basically the same leakage that you get with Poplar, which is good. But still, it's still it might not be reasonable to actually deploy this. Okay. So that's all I wanted to say about this problem at a high level. I think the main question is like, are we ready to support heavy hitters? And I just want to point out before I give it off to Tim, this is very much still it's a research question, how to solve heavy hitters. We kind of know that we know for sure it'll require differential privacy. We don't have a spec for this yet. It's also worth mentioning that there might be improvements that are possible if we kind of go beyond the current framework that we have. So with that, Tim, I'll leave it to you. I'll let you take over.
Thanks, Chris. All right, let's give Meet Echo a shot. I want to see if I can request the slides here. I'm not sure if you need to surrender control, Chris.
Yeah, Tim or Chris needs to stop sharing. Try it again, Tim. There you go.
Neat. Okay. Where were we? Whoops, that was it. Okay. Thank you. Okay, so I want to double down on what Chris was just observing about how, yeah, doing heavy hitters effectively there are some open research questions there. I bring this up in particular to draw a contrast with the Prio stuff that we have been working on, where there I think we have a much firmer grasp on like how it works, what the security characteristic is, and indeed how to deploy it. So I think this is very significant, this distinction, when we're discussing like in which draft shall we address which problems. All right. So in this next section of this presentation, what we have here is a few questions, sort of questions put to the working group that we as editors of DAP have come up with. Now, obviously, it's the it's the responsibility of the chairs to sort of formally put questions to the working group, especially keeping in mind like the attendance today. But what we want to do as document editors here is sort of get on the record, first like the statement of the problem that Chris just gave us, and now our view on what we think we could do about it, especially as we have sort of developed these concrete proposals about changes we could make to documents and text we could go right. So there's a couple of different questions we're going to work through here. And what I want to do is go through the questions and then spend some time fleshing out the proposals that we have for like how to address these things. And then once I've done that, then I think we can consider as a working group, like how we want to answer these questions. Okay, so yeah, the highest level question here is, should DAP, distributed aggregation protocol, support heavy hitters? All right, another thing we have to tease out here, right, is that DAP is not necessarily the only product of the PPM working group. So even should we say that DAP doesn't do heavy hitters, that doesn't mean the PPM is giving up on the question, right? It would mean that we might envision addressing heavy hitters in a sort of a parallel or separate document. Which, as we note here, a lot of it would be borrowed from DAP. Like, for instance, I think we would come to observe that, say, the upload interaction for reports would look exactly the same, basically. And probably a huge part, if not all, of handling of aggregation jobs between aggregators would look very similar. What ends up behaving differently is sort of the collection backend. So yeah, so the draft that we've got that does DAP, it currently sort of is well suited to handle the Prio3 family of VDAFs, Mastic, which is yet to be adopted anywhere, which we could use for cases very similar to Prio, but in this case, we'd be using it specifically for attribute-based metrics. And the Pine VDAF, I forget what the P stands for, but it's inexpensive norm estimation, which is specialized for machine learning model training. Okay, so this brings us to sort of three different concrete proposals that we as document editors have for how to move forward here. In proposal number 0, we would say DAP will not do heavy hitters, and then we get to specialize DAP to just the case where each report or each batch gets collected exactly once. If we do choose to support heavy hitters, then we have 2 different proposals for how to handle that, which we'll cover in the next few slides. And I would note here that even should we decide that we don't want to do heavy hitters in DAP, what we're laying out here in proposal 1 and 2 could still inform sort of a separate document that PPM would take responsibility for drafting. Okay, so if we do want to deal with heavy hitters, whether in DAP or outside of it, then the question is, what are we going to do about steering attacks? So over the last few weeks, in collaboration with a whole bunch of folks that Chris acknowledged earlier, we've been elaborating what are sort of the Sam?
Yeah, shall we go try and answer these in order, or have discussion on them in order, or do you want to try and frame it first?
I think it's worth going through the list first.
Yeah, so we want to like enumerate these goals here, these mitigations that we feel are necessary, and also I want to spend a little time just showing what are actually the document changes we're talking about here, because I think that helps inform, like, does this belong in DAP or does it fit somewhere else? Okay, so right, so we covered steering Chris steered us through steering attacks earlier, and what we've come up with is this set of mitigations that help to eliminate some attacks or some information leaks, or limit others. So what we can do is enforce, we can require that the tree traversal is consistent, which means concretely that every node visited has to be the child of a previously traversed node. This stops the attacker from say, finding that there's a heavy hitting node, let's say on the right side of the tree, but then deciding like, oh, I'm going to steer down the left side of the tree of the next round because that seems more interesting. We can also have the aggregators reveal prefix counts at each level to each other, because then they could enforce the property that the weight of each node visited must be equal to the sum of its children. And this limits the ability of the attacker to redistribute weight across subtrees. Similarly, we can have the aggregators commit to shares of the prefix count at each collection. The idea here is that we want to deny the attacker the ability, we want to give the attacker the least amount of information possible when it is executing the additive attack that Chris described earlier. So if we don't force commitment, then the attacker gets to see the honest aggregators share the prefix counts when it's constructing its own share. And finally, we can require differential privacy, which, as we saw before, mitigates additive attacks. And we should note also, and again, this is something of an open question, applying differential privacy noise to aggregate shares can, to some extent, complicate some of these mitigations. Because, for instance, ideally, you'd be able to verify that 2 child nodes their weights sum up to exactly the weight of their parent. But in the presence of differential privacy, you can't have an exact comparison like that. So you instead have to define that the weights have to sum up to the parent within some bounds that are a function of the differential privacy parameters that were chosen. Okay, so now we're gonna, excuse me, just taking stock of the slides. Yeah, right, now we're just gonna look at the concrete proposals that we have for how we could tackle these, how we could apply some of these mitigations in DAP. So the first proposal involves, we think, the least intrusive changes to DAP. They fit the most neatly into DAP. The way this works is that essentially, as you would think of it today, the collector is responsible for driving traversal of the tree. So what that means is we have to allow each batch to be collected multiple times with a different aggregation parameter. And each collection of a batch means going down one level of the tree. So what's needed here, the changes to the specification that are required for this are, we have to introduce the ability to have aggregators hold on to reports across multiple collections of a batch, and add code paths for running aggregation jobs that sort of refer to previously transmitted input shares, or report shares rather, instead of having them always included in line. So the idea here is, if I'm aggregating over bit strings that are 1024 bits long, I'm aggregating over the same set of reports each time, and it would be wasteful to have the leader retransmit report shares at every single level of the tree. So this is just about introducing a message variant that says, aggregate over these reports that I sent you previously. There's also a number of tweaks we have to make to report validation rules implemented in the leader and helper at aggregate job initialization time. These are spelled out in detail in a Google Doc, which is linked at the end of this slide deck for those of you who haven't already seen it or indeed contributed to it.
And this is the one that you sent to the list a week or so ago.
Yes, that's correct. And there, I see Chris Patton just put a link to it in the chat here.
Wonderful.
Okay, and yeah, we'll get to trade-offs in a minute. The second proposal is significantly more disruptive. Here, we would shift the responsibility for driving traversal of the tree into the aggregators. So in the previous setting, right, the collector is involved at each collection of the batch and saying like, okay, let's go down these nodes that we believe are heavy hitters. In this proposal, the aggregators get to see the prefix counts at every level of the tree. And at that point, they're able to independently decide what are the heavy hitters and which subtrees to traverse. So the collector would just say, give me the heavy hitters, please. The leader and helper would then, on their own, do as many collections of the batch as are necessary, and then simply deliver the set of heavy hitters back to the collector. Let me finish this slide real quick, Benjamin, and then I'll take your question. So this requires all the same changes as proposal 1, but we also would have to define a new notion of like a different kind of collection mode, where heavy hitters would be one particular collection mode. We have to introduce a commitment scheme between the aggregators. And the other thing is that this introduces heavy hitters specific semantics at the DAP layer, which to some extent pierces the veil of abstraction of VDAP. And so we lose some measure of generality relative to where DAP is today. Benjamin, go ahead.
Hi. Yeah, I have a couple of questions about this. Why, first of all, does this really require all of the things discussed in Proposal 1? If the aggregation logic is defined to be something that the aggregators do, then can a dishonest aggregator really mount one of these additive attacks or steering attacks? It seems like the behavior is all prescribed within the specification, and it would fail. It seems like it would fail to merge. You wouldn't get sensible output.
Let me flip back to, that's the one. Okay, so this is the slide that illustrated how an additive attack would be run on the prefix tree, right? So
right.
Consider that at this level of the tree, the way that we have this illustrated here, right, is that we're doing this additive attack against like the real prefix counts, which are the sum of the aggregate shares that were constructed at level 1 of the tree here. So the aggregators, in fact, they don't get to see this. What they get to see is the aggregate share that each of them constructed. So instead of 2 and 30, right, what they'll see is some random looking value in the field on the one side, and then same on the other side. And when you sum those shares together, they sum to 2 and 30.
Okay, okay. So in that, then how is proposal 2 supposed to work if it continues to use that representation? How can one aggregator do part of the heavy hitters computation when it cannot tell the difference between heavy hitting and light hitting prefixes?
I see what you mean. In proposal 2, the aggregators would reveal their aggregate shares to each other, such that aggregators could independently then each on their own decide like which are the heavy hitters and thus what are the correct subtrees to traverse.
Well, okay, independently in the sense that they each have a lot of information provided by the other aggregator.
That's right. The important thing, okay, so if we did it like as DAP today or as in proposal 1, then the collector has complete power to decide what subtrees we're going to traverse, right? And the idea is that in proposal 2, we shift that responsibility into the aggregators, but on top of that, enable either aggregator, we give either aggregator all of the information necessary to decide which subtrees to go down so that they can sort of, neither aggregator is trusted to just sort of arbitrarily choose what subtrees to traverse. But either aggregator can still do these additive attacks to sort of add weight to the wrong side of the tree.
How many rounds of communication does this end up with between the aggregators?
The same number of rounds as you would have had between the collector and the aggregators, which is to say the depth of the tree.
Yeah. Okay. And is that the reason why this is considered not a VDAF? Because of that, you know, if we could do this without any communication between the aggregators, so they, you know, in a single round back to the collector, would that make it qualify as a VDAF?
It's still a VDAF. You would still be using like Poplar or Mastic articulated in the shape of a VDAF. But when I say that this pierces the abstraction, what I mean is that like in DAP today, our beautiful dream of DAP was that it could operate completely generically over VDAFs. And that at most you needed to have this affordance of being able to collect a batch multiple times. And that would suffice for heavy hitters. Like, right? And then the hope was that, so for instance, in the case of heavy hitters, concretely what we're doing when we do multiple collections of a batch is going down levels of the tree.
Yep.
DAP didn't need to know about that. At least we were hopeful that it didn't need to know about that. What proposal 2 concedes is like, no, we actually do need to sort of introduce those semantics at the DAP layer. Like the DAP aggregator needs to become aware of like what are these intermediate collection results, and how does that inform like the next thing I'm going to choose. So it's like some of the details of what the VDAF is actually doing kind of leak into the DAP layer.
Okay, thanks for that explanation.
Okay, so that's that. Okay. So then we have this, summary of like, but basically trade-offs between proposal 1 and 2. So I mean, not shown here is proposal 0 because the trade-offs there, but just that like we don't really do heavy hitters. So the considerations here are, if proposal 1 is less intrusive to the spec, it like fits the model, the philosophy of DAP better, whereas proposal 2 is quite intrusive and disruptive. In proposal 1, the collector still gets to learn the whole prefix tree that we saw illustrated in that slide earlier, where there was the distinction between like what we wanted to learn and what we sort of unintentionally learned. In proposal 2, however, we can conceal all the prefix counts, including the counts of the leaves, the actual heavy hitting strings, from the collector. Because we've shifted the responsibility of tree traversal into the aggregators, we can reveal nothing but the set of heavy hitting strings to the collector. Proposal number 2 is probably faster. This says optimal latency, which is a bit strong. But the idea is that in proposal 1, you still need to have the collector in the loop for every collection of the batch, which isn't strictly useful because a priori it's doing this deterministic, the decision of which subtree to traverse based on the current collection's prefix shares ought to be deterministic. So adding the collector into that loop doesn't actually gain you anything except like more latency, more waiting on messages. As we were just discussing, proposal 2 is less generic. It is less general across VDAFs. So we would need to introduce some notion at the DAP layer of this heavy hitters collection mode and the heavy hitters semantics to the aggregators. Finally, proposal number 2 would complicate this optimization that we've been sort of hand waving around for a long time now, which is level skipping. So the short version of this is like, heavy hitters is about aggregating over bit strings. But let's suppose that you have specific domain knowledge, right? That like the bit strings that you're aggregating over are actually ASCII text. So then instead of doing one collection per bit, you might say do one per ASCII character and skip like 8 levels at a time. So that's possible in Proposal 1 because we leave the choice of the next set of candidate prefixes to the collector, and it's not specified in the protocol, which means that the collector could, apply this apply these application-specific heuristics to choose these things. If we wanted to do something like level skipping in Proposal number 2, then the aggregators need to know what the strategy is, and that has to be sort of agreed upon somehow. Okay, so that's the rundown of Proposals 1 and 2 and the questions here. So I believe, the last thing I'll note before I ask the chair some stuff is we have a couple links here to some more reading material that give like a lot more detail on all this stuff. And yeah, with that, chairs, how do you think we should proceed with these questions?
Being very aware of the attendance today and how many of the people on that list have been involved in this design team. What is your proposed favorite of these answers?
So, okay, I should be careful. I can speak for myself here. Sorry, Benjamin, did you want to say something first?
No, I'm just coming on to support the chairs.
Okay, so I can speak, I think, like for myself personally, and I think to some extent for like my colleagues at ISRG. We've been talking about this a bunch. In my opinion, what we should do is Proposal 0, which is to say, don't do heavy hitters in DAP, but heavy hitters is in the charter for PPM, and I strongly believe PPM should still do it. But I don't think it should be done in the DAP draft. So I want to lay out a few arguments for this. The first is, again, as Chris led us through, the Prio stuff, or the stuff around like running VDAFs that have that shape, which includes Pine and Mastic in attribute-based collection mode. I think that stuff is much more mature. We have a much better handle on how it works, what the security properties are, and how to run it. Versus heavy hitters, which regardless of whether we do that with Mastic or Poplar or something else, there's some open questions, and particularly the differential privacy stuff, I think needs a lot more attention and thought. So I think that so for that reason, I think we should split those two things out. Like the best path that we have toward, say, getting a DAP RFC that tells us how to run Prio, I think, is to focus in on the stuff that we have like high confidence in how to run safely. Ultimately, the other thing is I think the question of like, what do we do about heavy hitters at all, regardless of in which document? I lean towards Proposal 2 because I think it has better properties in terms of minimal information leakage. But here's the thing. What we've learned from like thinking about this problem for a while is that you really end up wanting a protocol that is aware of heavy hitters, but is specific to heavy hitters, because there are semantics that aren't just sort of generic across all VDAFs. They are particular to the heavy hitters problem. So I think that the way that we get to like documents that do a good job of solving like the Prio case and the heavy hitters case is to write 2 documents in PPM, each of which is specialized to those use cases. I think we end up with 2 strongly focused and higher quality documents, as opposed to 1 document that's trying to be this meta protocol and has like these awkward and overly generic affordances.
Gotcha. I'm going to go ahead and take folks from the queue and hear whatever viewpoints we hear, and then I'll have some questions for the rest of the group. Chris?
Yeah, I'm supportive of Proposal 0 as well. I think there's 2 things I want to warn people about based on my experience and what I know. The first is that I don't think that we're going to do much better than IDPFs plus differential privacy. So I would not. I would just not hold out hope for like some magical like black box that comes and solves our problem. So I think the future draft I think I think the future draft would specify the whatever VDEF we go with plus the differential privacy bits, and I would really like to see like end-to-end security analysis for that. The second point is I've implemented proposal 1, and I want to just point out that there's not really a natural way of making a DApp implementation purely agnostic to the VDAF. So for efficiency's sake, there's going to be details of the VDAF that bleed into your implementation of DApp if you're doing something like heavy hitters. So I think, so like from that perspective, I think proposal 1 is not really that much. There's not much of an advantage of 1 over 2. So I think, if we do have the separate draft, I also think it should be number 2.
Thanks, Chris. Shan?
Hey, I have a question regarding proposal 2, maybe related to proposal 1 as well. Apologize if the Google Doc already explained this, but why in proposal 2 we have to have these multiple rounds between aggregators? Can we not communicate the levels we want to traverse as a fixed parameter when we configure the task, and when we collect only reveal the heavy hitters for those purposes and above that threshold?
So the reason that you need multiple rounds, for one thing, when you're doing heavy hitters, you have to have multiple rounds regardless of whether we're doing proposal 1 or 2. That's because we have to traverse every level of the tree, and then we don't know at any given level of the tree, we don't know which path we want to take down the tree until we have evaluated the prefix at some level. Sorry, let me try to rephrase that more clearly. We don't know what nodes we're going to traverse at level n+1 until we've evaluated the prefix counts at level n. That's true, again, so some actor in the protocol has to evaluate what are the prefix counts we discovered at level n, and then choose the next set of candidate prefixes. And you can't do that ahead of time because you don't know yet what the prefix tree is. Shane, does that go to your question?
Yeah, I think so.
Okay, so again, I think the key point there is whether or not you do multiple rounds is sort of orthogonal to whether it's proposal 1 or 2.
But in 2, we have a lot of message passing between the aggregators that the collector never sees.
Yeah, that's correct. Although for what it's worth, my intuition is proposal 2 should be strictly less message passing than proposal 1. Consider that in proposal 1, you would have at each level of the tree, the collector would initiate a collection, like send a request of a leader, which in turn would cause the leader to request an aggregate share from the helper. So there's still leader-helper communication there, right? All we're doing really in proposal 2 is taking that collector to leader edge out of the graph.
Armando.
Hey, hello. So I just want to make a comment about the DApp draft. It seems to me that this was a good effort to generalize the protocol, but actually the actual instantiations are few of them. I don't think it's actually fulfilling the right abstraction in collaboration with VDAPs. So yeah, I think I agree with what Tim says about going with specific documents about one specific proposals. Let's say in this case heavy hitters, or one specific algorithm for doing that. And what else? Yeah, yeah, I would be more leaning towards having a dedicated document for that. And in the future, it is needed some other better algorithm or better construction that can be revisited.
Thank you, Armando. Tim, I saw you queue. Did you want to, or shall I?
I guess I just wanted to double down on Armando agreeing with me. But sorry, specifically that I wanted to add that I think the VDAF abstraction remains useful in that I think there's been some interesting work that's been done, like say proofs that have been written around VDAFs as an abstraction. But yeah, the path going forward, I think, would be to write documents in PPM, each of which maybe spells out like how to run a particular VDAF or how to use some like category of VDAFs to solve a particular problem. Yeah, rather than a DAP level document, rather than a PPM level document that tries to be able to run any VDAF conceivable. But the point I want to make though is that like, I think it was still useful to have this sort of object of the VDAF as distinct from the higher level protocols that run them.
All right. So the obvious question, does anyone on the call dissent in this and think that we should not take heavy hitters out of the base DAP draft?
Simon's in the queue.
Go ahead, Simon.
Not sure if this is working. Can you hear me? I'm not dissenting specifically, but I think there is some issue that we should discuss about which parts of the current DAP we are throwing away if we are throwing out heavy hitters. Because some of the protocol parts will be unnecessary, and depending on whichever draft or new proposal this comes back in, people might still want to do similar things in their implementations. So I'm not an implementer, so it doesn't specifically concern me, but I think we should discuss a little bit if we keep options for doing multiple rounds or if that just doesn't matter. But I'm not dissenting with proposal 0.
Go ahead, Chris. We're small enough we can just have a discussion, and Ben and I can interrupt as we need to.
Okay. So Simon, I think so just so everyone's on the same page, by multiple rounds, he means rounds of during the aggregation sub protocol where you're actually doing the multi-party computation step to actually do the validation. So right now we allow any number of steps. Concretely, Poplar requires 2, Prio requires 1, Mastic and Pine both require 1. So if we decide we're never going to implement Poplar, then we can simplify the protocol there. So I think as an editor of that draft, I think it's as an editor of both Poplar and Mastic, it's I'm not confident that Mastic is even going to get adopted, given CFRG's lack of interest in taking on new work in the space, which gets to a broader conversation we can have about what things should PPM do versus CFRG. But regardless, I think that we have to. I think I would not make that simplification yet, just because we don't know what the future of Poplar is.
So the question Simon raised was, what would we delete out of DAP if we go proposal 0? And it's not that much text really, but rather I think we end up deleting like disproportionately complicated stuff. So in particular, we now get to state very clearly a batch gets collected once, just like one time when you're running something like Prio or Pine. And yet there's like there's a good amount of messy language around how do you know whether to allow more collections and so on that just like goes away. I'd also note that we have more details in the Google Doc that is linked at the end of this slide deck about like how each proposal would resolve some number of open issues. So there's a more fleshed out picture of what this actually manifests as protocol changes in there. David, I saw you peek into the queue.
And
I was going to say what you did. That's good.
go ahead, David.
Can you hear me? Okay, yeah, I was just going to say what Tim did about eliminating multiple collections. So that was it. Thanks.
Simon, how is this doing at answering your questions?
Yeah, I think sounds good to me. I mean, if we don't take back too many things, that makes me even happier.
I think the minimal change is kind of spelled out. We just disallow multiple collections. There's that parameter in the task config that we just remove, and probably not mention Poplar in the base spec unless we think there's a use case that it actually solves that we can support.
Assuming, and we'll come back to how we're going to resolve this, that we choose the option 0. Let's go to your second question about path forward for heavy hitters. I was hearing you proposing, I was hearing both Tim and Chris being fans of option 2, where the aggregators compute the prefix tree on their own. Same question as before, is there dissent on that choice? Simon?
I think if we're treating this as a research problem, and I think that's a pretty good stance to take, then it makes sense to also consider doing this with multi-party computation, maybe with more parties, whatever. But I think it's not standards writing work, but something, to be worked on first.
Yeah, so I think Simon's perspective there is valuable in that a big part of the motivation to me for, say, doing proposal 0, or rather to focus DApp on VDAPs that have the PRIO shape, is that I think that that's our best path to getting an RFC that like lets us run PRIO. So similarly, I think there's we might apply a certain pragmatic lens to what we want to do about heavy hitters, in the sense that there's probably is like a few different exciting, at least novel compositions of cryptography that we can do here, right? Like I think what Chris spelled out would be like an honest majority 3-party computation of the prefix counts. Or like I have this very half-baked notion that you could do some kind of a shuffle so that the aggregators don't know like what the nodes are, but they're working on a given level, stuff like that. There's probably a few different interesting things we could do there. The question is, would it be worth our while to invest in like a less ambitious heavy hitters? Say one that uses like basically say one that does proposal 2 and has limitations that we know about, and then write a document based on that, so that again we can like produce something that is a stab towards heavy hitters that then further work can iterate on? Or would the working group want to like wait for some interesting new piece of research to come about?
Something concrete, maybe not as generalized and flexible.
Yeah, like a concrete solution to the heavy hitters problem that has, but here are the caveats, here are the problems with it. Like, is that worth the while of an IETF working group if we don't necessarily have confidence that people will go deploy it? But is it useful as a point of reference against which like future research and future work can compare itself?
I'm most interested if people want to actually use it. Chris?
Yeah, I was just going to say exactly what you just said. I think a standard is not supposed to exist as a straw man. It's supposed to be for something that people intend to use. So that's the purpose of it.
Yeah, there was part where we were talking about taking things out and how people might want to use them. I was thinking we could have an appendix that says if you're thinking about modifying this, here's directions we go. But I don't really want to be writing RFCs for things that people are unlikely to use.
Yeah, just along those lines, something a comment that Simon made in the chat, like Star. I mean, like Star was in his example of a protocol that a group of people wanted to use, and we're trying to get other people to get behind, and this working group kind of, decided not to take it up.
So do we have, who wants to work on the heavy hitters stuff actively?
I think we do. I'll say I do. I'm pretty sure my employer does, but I can say I do.
I think my employer would like this as well. Like we have definite use cases for this. I think the approach that we would take is prototyping and deploying for a real use case before we even brought it to IETF. This experience, I think we've learned a lot from like what we can do. But yeah, I think this is probably a while out for us.
Shen?
Yeah, I was going to say the same thing. I think we are interested in the use case. We're just not sure the exact method we're going to use.
Great.
Yeah, but I think we could make a lot of progress, like experimenting with this in our respective organizations, maybe even like throwing individual drafts up on data trackers as needed. And then it probably would be wise to like not adopt something until we have much more confidence that like, yeah, this is a viable solution that people would actually want to ship.
Great. So given, again, the attendance today, I think we need to take the consensus call to the list, which I'm taking as we are pulling the heavy hitter support, and particularly the multi-round communication support, out of DAP to simplify the draft. We are entertaining work on heavy hitters, knowing that that's going to be back at the ID phase, and we want it to be deployed along the way. I'm not staying this well, but I think that's what we're going to propose. Ben, does that sound right to you?
Sorry, can I just ask what is ID phase?
Sorry. We're going to be seeing some internet drafts, including some individual drafts rather than working group drafts.
Oh, I see. Thanks.
Yeah, this has been a great discussion. Thanks everybody for being willing to entertain a big change here. I think one of the interesting questions that comes up to me is heavy hitters really an early stage research problem?
Can you repeat that? You cut out for a second, Ben.
I think he is cutting out. What I heard is heavy hitters really an early stage research problem? Like, is it ready for the group? And Ben is completely frozen. So, and my own intuition is that it's not that early stage, and that it is ready for this level of. We should be discussing individual drafts in this working group. Is my intuition, but.
Yeah, so I think it has one dependency that we have not resolved, which is we need to spell out like a Laplace mechanism for differential privacy that people want to use. So there's the DP draft that was presented a couple of IETFs in a row, and I'm not sure why, but there seems to be. I mean, generally speaking, there seems to be people don't seem to want to adopt new work in this working group. But I'm just suggesting that like I think all that's required to kind of standardize IDPFs for this problem is a common understanding of how to apply differential privacy to this particular protocol. And people talk about the possibility of using fancier or different crypto. That hasn't panned out yet. It's still a possibility, but I personally don't think it's worth holding out for. I think we know of a workable solution, and it's just about having the will to implement that solution.
Great. Tim and Chris, are you happy writing that proposed change up for the list, given how much work you've done here, or do you want the chairs to do it?
So you're talking about summarizing like what we would do to DAP and what the shape of this new heavy hitters thing would be? Yeah, absolutely.
Great.
If you want, we can put together a PR for the spec too.
So I think we've resolved the main topic on our agenda. Junior had asked for time to talk about Pine. I propose that we all take a 5-minute break, come back here at 10 minutes after the hour and do that. Any objections? Great. I'll see y'all in 5 minutes. We'll be talking about Pine. Welcome back. I hope everyone enjoyed your break. I love being able to take a break in the middle of our working group meetings. Junye wanted to talk about Pine. Junye, do you know how to share slides?
Sure, yeah. Sam, is there any way you can present the CFRG slides, or
Yes, or you can. So
I
if
can
you,
as well.
at the bottom of your screen, the fourth button is share slides,
Okay.
and I uploaded those slides for you. Oh, shoot. Try it again.
Pulling up the slides.
Here we go. Let me put them up and see if I can give you control. All right, I have them up. I can run through them.
Okay. Let me try requesting control.
There you go.
Oh, cool. Okay, that works. Okay. Hi everyone. Today I'm going to give a quick update of the new VDAF called Private and Expensive Norm Enforcement, or in short, PINE. This is a new VDAF to support federated machine learning use cases, which is a use case for the PPM working group. This was also presented in the CFRG working group, but I want to bring this VDAV into this audience as well to make sure people know that this is an option to basically support federated machine learning use case on DAP. This is a joint work with Chris Patton. I'm going to briefly talk about the use case first. Here I have a list of devices on the left. Each of them trains a machine learning model, denoted as F here, with its local data. Each client then generates a model update vector, which we also call gradient. And to improve the model, we have this central server on the right that collects the gradients from the client. The server then aggregates the gradients and applies the aggregation to the model, and we get an improved model called F prime. And then we send the new model back to the clients to repeat this process in the next iteration. So it's great this process doesn't require us to collect the client data directly, but the model gradient still leaks very sensitive information about the client, so we want to see if we can do better in terms of privacy here. One solution is to leverage the VDAF framework to remove this trust on the central server, which this working group is heavily involved on. VDAF is basically a secure multi-party computation protocol that can aggregate client measurements with privacy and robustness. And the base VDAF draft specifically provides a spec for Prio 3, which uses the idea of a fully linear proof, or in short, FLP, which is basically a distributed zero-knowledge proof system that can verify certain properties in the client measurements. This ensures we don't learn anything about each individual client measurement, but still able to ensure the robustness of the system. Therefore, we have proposed this new VDAF called PINE, which is based on a recent paper with Guy Rothblum, Iran Omri, and Kunal Tower. This new VDAF is used to compute an aggregation of the client gradients, expressed as vectors of real numbers. And to ensure the robustness of the aggregation, we require each client gradient to have a bounded L2 norm, which is defined as taking the square root of the sum of squares of all gradient entries. It uses a similar idea of a FLP like Prio 3. And if we were to simulate this in the VDAF framework, Here I basically replaced the central server with 2 aggregators, 1 leader and 1 helper, and the collector collecting the final aggregations from the 2 aggregators. What client does is it encodes its gradient into a vector of field elements and generates a proof to prove its L2 norm is bounded. And then secret shares its encoded gradient and proof and sends them to the 2 aggregators. The aggregators then compute some results over their respective secret shares and exchange the results to determine the validity of each client gradient, basically to verify the L2 norm is bounded. Each aggregator then produces a share of the gradient aggregation and sends it to the collector. And finally, the collector combines the 2 aggregate shares and applies that to the model to obtain a new model F prime, and we repeat this process by sending the new model back to the client. So why do we need a new VDAF to support this? Why can't we use Pro3 directly? That's because computing a squared L2 norm in the field element operations can overflow the field modulus. Here I have given a simple example. Suppose your L2 norm bound is 10, the field modulus is 23, and I have a clearly invalid client gradient that's 99, 0, and 7. And taking the square L2 norm of this gradient modulo Q is only 6, which can cause the aggregators to incorrectly accept this client gradient. As a result, we'll corrupt our machine learning model, and we certainly do not want that. So the challenge here is how to prevent or detect this wraparound effect. One way to address this problem is to make sure each gradient entry is sufficiently small. For example, we can represent each entry with bits and use a VDAF like Pro3, but a solution like this will incur an extremely high communication cost that's infeasible for high dimension. And the cost is approximately in the order of dimension times the number of fractional bits you want to keep in your gradient. So Pine proposed this innovative idea of checking for this wraparound effect. The high-level idea is we'll generate a random vector of -1, 1, and 0, and compute a dot product of the random vector and the gradient. And if the norm computation overflows the field modulus, this dot product is likely to be large. And in our paper, we prove this check can correctly detect this wraparound effect with probability at half. So an invalid gradient may still be accepted half of the time. And in order to achieve the desired soundness error, we basically repeat this check many times. And because of this need to sample this random vector, this is incompatible with Pro3 because we need both the clients and aggregators to independently derive this random vector on their own. Here are some quick performance comparisons. It turns out with dimension of your gradient to be 100K, Pine can achieve a 15 times smaller communication cost between the client and the aggregators compared to a solution with Pro3. Finally, some next steps for this draft. The current status is we've completed the core design work. We have implemented some reference code and generated test vectors for it. The core component will be supported by the security proofs in the paper. We plan to complete the draft text next and finalize some parameters to optimize for communication cost. And we'll, in the meantime, incorporate feedback from implementers. There wasn't much interest adopting this draft in CFRG, but I think people in the PPM working group will probably be more interested in this draft because this basically enables a new use case of federated learning on DAP and VDAF, and shouldn't require any changes to the core protocol, and it can improve privacy and robustness for training machine learning models. And I think that's it from my presentation. And I want to see if people in this working group is interested in working on this. So I welcome questions and feedback. Thank you.
What was the reception to this work in CFRG? I admit that I didn't watch it.
I think people just wasn't very familiar of the VDAF wasn't familiar about the VDAF draft, so they weren't sure about like the scope of this and the impact of this. I think that's generally my feeling after presenting this draft.
Thanks.
So first off, my impression from having attended the CFRG session in question, I'm sorry, cat. Yeah, so the issue I think at CFRG is that it's not clear that the members of CFRG have like the necessary expertise or appetite to look at, I think, MPC, and to some extent there's some measure reservations around machine learning. One of the things that we did here at CFRG clearly was that before they would take on, it was Pine in particular, they wanted a clear statement from an IETF working group, PPM specifically, an affirmation that we're interested in this stuff, like sufficiently interested that CFRG should like take on this work. That being said, my read on all this is that it's not clear to me that CFRG is a great venue to do MPC work. It doesn't seem like what they've wound up specializing on doing. So sorry, coming back to the question, like what to do with Pine. So first off, I support this work. I think this is interesting stuff. So far as I know, it should fit neatly into DAP because it has like the same sort of shape as Prio 3 in the ways that we've been discussing. And I think that the machine learning use case like is quite compelling. There is a fair amount of industry interest in doing this stuff privately. So I think this work should be done. And then past that, I'm not aware of a better place at the IE or IRTF to do this work. Like I say, I'm not optimistic about CFRG doing it, and then I don't know of a better home for it than PPM. Mind you, that comes with some caveats. Like, I'm a little concerned about PPM becoming the de facto home for certain topics, like say differential privacy or certainly machine learning. But as far as like looking at this as a MPC aggregation problem, this does seem like a reasonable venue in which to take on this work.
Hey, John, could you please talk more about like the choice of the modulus prime? So you mentioned that that operation can wrap out, but what if you actually choose a larger prime for that, for doing computations?
You mean the prime number in the field element?
Yeah.
So I think the choice of field element, field size impacts robustness. We definitely want to. It also affects communication costs. So I think we want to strike a balance between achieving a reasonable robustness and also make sure that communication costs between the client and the aggregators do not just blow up. So I think it shouldn't impact your model accuracy. The aggregation of the model gradients should be exactly the same as if you were to, directly compute a summation of the client gradients directly outside of VDAF, for example.
Yeah, it would be good to have like an overview of how those the parameters are involved, but for, or at least for the communication, because robustness I think is it's easier to show. Yeah, I think I support like this work, and yeah, I think it's good to have it here, at least in PPM.
Sure, I think one of the few remaining work is to try to finalize parameters to minimize communication costs, also to and the security analysis to achieve the desired robustness we want to achieve.
So I wanted to just add to Junier's original answer to Armando's question. So picking a larger modulus doesn't really help with wraparound effects, because you can just, if you want to pick a gradient that wraps around the field modulus, you just need to pick bigger entries if you have a bigger field. So the key thing that's needed is either you need to encode your inputs in a way such that wraparounds just don't happen. And in fact, there's like a way we can do this with Prio, but Pine just does a different thing and lets you do so in a much more communication efficient way.
I'm guessing that this should get more air on the list. Ben, you have words.
Yeah, so it's clear that there's a lot of interest in this topic. I have a question for all of these folks. You know, we've heard a lot of questions about where work gets done, and I think there's a little bit of a football here, where the IETF tries to stay away from cutting-edge computer science research, and CFRG tries to stay away from topics that are outside of its focus of expertise, and a lot of these recent PPM items seem to be falling through the cracks. I wonder if, as Tim maybe was hinting at earlier, whether it's time for a multi-party computation IRTF group that could be a clear official partner for PPM and a place for these kinds of discussions. That is not something that we can decide in this group, but I wonder what people think about that, or about other ways to structure this work. Or, you know, do you think that we should really just try to do it all in PPM?
I mean, so on the one hand, like, I feel like creating a working group to sort of generalize what we're doing, it only really works if the experts are showing up. And I think if you identify the right problem, we have a football problem, but like we don't have the community really developed around this protocol, like this space of cryptography, at least within the IETF. Something that we've tried to do over the last couple of years with mixed success, I'd say. That said, I mean, some folks have heard rumblings about what Meta wants to do with IPA and sort of the generalization of that framework. And there was a side meeting at the last IETF about like kind of the future of that. It's sort of like, you know, like PPM is a small group. We have like at various points, like not necessarily like explicitly decided to not do new things, but there hasn't been the energy here to take on new things. And we're really only taking a bite out of a very complicated problem. So there's NPC, but the other very important part of this is differential privacy. Differential privacy is going to be needed in any application of DApp pretty much, because it's what you mean when you say, is the protocol secure? You're asking, is it differentially private? So I would say, like, I'm strongly against considering like I don't think a BOF for MPC stuff is I think it's premature. I just don't think there is a critical mass yet. Yeah. Anyway, that's my view. This work in particular, like, I think this is exactly the kind of thing that DApp we want to be able to enable with DApp. Some folks write this paper. It fits fairly neatly into our framework with a few changes, and we have with DApp/Pine. I think we have like a really nice solution to this problem. Maybe you can do better. The solution is maybe not complete. There's definitely still work to do. But like it's already really close to engineering. If you believe the proofs that exist, we're also on this slide. We're pointing out to some gaps that need to be filled. But yeah. Anyway, that's kind of a rant. But I think Pine's really cool, and I think we should all want to support this kind of design work.
Yeah, so I agree with everything Chris said. In particular, one of the questions before we would say go start a research group whose focus is, let's say, MPC, is who would be participating in that research group. And I think what we would find in practice is just what we've observed with the work on VDAF at CFRG, in that it's exactly the same people who come to PPM. So so I think if we were to start today this new research group whose job is MPC, then we would find it's exactly the same contributors who come to PPM, and I think we would just incur like the overhead of management of an extra group. I think to little gain, because the work that we're talking about here, say with Pine, and even other stuff to do with MPC, I think all of it like is perfectly well motivated by this working group's charter, because there's a clear line to like enabling the measurement work that we are signed up to do. That said, like I'm broadly very bullish on MPC. I think there's a ton of exciting stuff that could be done to make the internet, safer and more private using MPC. And I'm hopeful that in the coming years, like perhaps many years, there's going to be a lot of like very exciting MPC systems that'll get drafted up through IETF. Now, if we find in the future that like new IETF working groups are coming to PPM and saying like, hey, we want to cite this document that you're writing, or hey, we would like you to take on this piece of work because it'll help us, then that's a point at which I think it starts to make sense to try to like factor out some of these MPC primitives into something like a new research group. But for the time being, what we have is work that directly supports PPM and would be done by people who are already at PPM. So it makes sense to me to continue to do this work here.
Yeah, I have another question about Pine. Like, what is something that you cannot do with Pine? Like in this area of federated learning, what are the limitations?
I think any aggregations that you want to enforce some auto norm on your client measurement is suitable for Pine. We sort of use federated learning to motivate Pine in this particular presentation, but I think anything basically you want is basically it's specialized for auto norm verification.
So there are limits that we impose on not because of the paradigm necessarily, just because of the overhead. So you can't scale this to like arbitrary dimension, at least without some like protocol level like work. So like you're not going to use this for an LLM in the next 10 years. At least not, ChatGPT size.
You mean it's not possible, or that the scales it doesn't scale?
It's not going to scale to that application, because we're at like tens of billions of parameters. I'm not an ML person, but that's my understanding, is that like the dimension you're targeting is like tens of billions of parameters. And here, yeah, I mean, not knowing much about, just having read the paper, like my imagination is that we get to like, I don't even want to put a number to it, but I don't think this is for ChatGPT.
Yeah, roughly you can imagine the communication costs between client and aggregator is roughly, dimension times the number of bytes that you choose for your field size. The proofs is relatively a small percentage of it. So, but yeah, ultimately it's bounded by the dimension you choose for your application. Yeah, so there is some limitation, but I think like dimension is something I think pretty much every application, every VDAF will have to deal with. So yeah.
Okay, thank you.
Is this in Charter for us to take on?
I think arguably it is. I would argue that it is.
Okay.
The charter doesn't say machine learning. The charter says is more generic, but I think the spirit of it is to increase privacy when in these data collection applications. And I think ML is absolutely that.
I'm not worried about the ML part. I'm wondering about having the VDAF be here rather than the CFRG.
So the draft says we will use CFRG to work out crypto details as needed.
All right. That suggests that this is a candidate for an adoption call. Junior, thank you very much.
Thank you for letting me present.
Yeah. Absolutely.
Not to create chaos here with the multiple chairs chiming in, but so I have the charter here, and it says the PPM protocols will use cryptographic algorithms defined by CFRG. So I think, in the charter as written, we wouldn't be able to move forward here without certainly, a substantial CFRG involvement in the protocol definition, or some very some substantial reinterpretation of the charter.
But Pi itself is compatible with VDAF interface. Is that not a considered algorithm from CFRG?
VDAF, I don't think can be considered an algorithm.
I agree with Ben. I think the charter says CFRG takes care of crypto, and this is a crypto bit. So I think we would want to change the charter.
Our new AD, Deb, was not able to join us today, but Ben and I can have that conversation with her. Going back to the original presentation, I want to thank Tim, Chris, and everybody who was on that design team for the good write-up. And thank you all for the good discussions today. Do we have other topics for today?
Yes.
You want to look at the logo?
Well, now you spoiled the surprise. But yes. What do we got here? There we go. Okay. So yeah, Martin Thompson. Actually, I don't know, Chris, if you want to speak to this. I think you spoke to Martin about it.
No. Is literally just everything that's in the Slack thread is what I know.
Fair enough. Oh, there's a Slack thread. Sorry. Yeah. So Martin Thompson, apparently, I learned today, whipped up this pitch for PPM logo for us. There it is. So yeah, it's a plus split in two to represent the two aggregators. So I don't know if we need an adoption call for logos. I think it's neat. I've been reserving a little bit of space on the back of my laptop for a PPM sticker.
Now I'm thinking about IETF IPR rules and owning logos and blah, blah, blah. But that's not really what you're asking, is it?
I mean, I'm not asking about that.
I don't remember the details. It's not, you know, when I first saw it, I'm like, it makes some sense, but it's not quite intuitive. I don't care.
So the way Martin described it is it's simultaneously representative of the kind of the overall paradigm of secret sharing, but also the limitations of DApp. So this basically is DApp is just for aggregation. You're just adding things up. So that's why it's a plus.
Doesn't sound like you're going to get more of a consensus here today.
Yeah, let's move on.
All right. So
IETF, other than IETF logos do not require working group consensus. So the chairs will consult on logo questions. If you have comments, please bring them to the chair.
all right. So to summarize from today, Chris and Tim are going to write up the proposal for the heavy hitters path, which includes simplifying the DApp protocol, removing the multi-round stuff and heavy hitter support, and breaking out heavy hitter support into new drafts. And Ben and I need to have a conversation with Deb about whether we can take on Pine and how to recharter to do that. Yes, Chris.
So so that write-up exists. It's in the Google Doc. We could say more about what the separate document would look like, but it would basically be proposal 2.
Yeah. Yes.
So
But
what we can do is like create a couple of sentences on each, and just so you have something to do a consensus call with. Is that what you'd like to see?
what I would like to see is, based on the discussion at this interim, the editors are proposing this comment, and where this is no more than 20 lines.
Got it. Sounds good.
And can include the link out to that, and should include the link out to that document that explains it in more depth.
Thank you.
Yep. No, and thanks everybody today. Appreciate the attention and the discussion.
I've tried to take notes on all the interesting conversations here. If you spoke today, please double check my transcriptions and summaries in the Hedge doc, and then we'll put out some minutes once everybody's had a day or two to make any corrections there.
And to get to that document, in Meet Echo at the top of the page, there's the note-taking tool icon that will get you to that document. SW is Shan Wing and SamW is me, right?
Feel free to correct any names that I maybe have wrong or have rendered ambiguously.
I don't think SW is me. I didn't ask a question, what do you think we should do?
I'm sorry, I missed that. I'm going to end the meeting. Or, oh, I guess I can't end the meeting. We just have to leave the room.